Trigonometry, Chapter 3, Radian Measure in the Unit Circle, Section 3, the Unit Circle and Circular Functions, Video 3, Circular Trig Functions. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we completed the unit circle. We identified the coordinates of the points associated with 30 degrees, 45 degrees, and 60 degrees in each quadrant. We started with quadrant 1, reflected into quadrant 2, reflected both to get quadrants 3 and 4, and basically measured 30, 45, and 60 degrees as reference angles in each quadrant. In this video, we define the circular trig functions on the unit circle. Now, the circular trig functions are functions whose input is a point on the unit circle. So you pick a point on the unit circle and you hit it with trig. Now, while each point on the unit circle has two coordinates x and y, we can also view each point on the unit circle in terms of the arc length from 1, 0 to that point, and we will call this arc length s. So in other words, every point is associated with a single number. How far did I travel to get there, starting at 1, 0? Now, each arc S is associated with a unique point x, y in the unit circle, but each point x, y in the unit circle is not associated with a unique S. Why? Because if I add another revolution, which is like adding 2 pi to S, that essentially creates coterminal arcs with the same point. It should also be pointed out that each arc S is associated with the central angle theta. And since the radius of the unit circle is 1, then the radian measure of theta is equal to s. And the reason why for that is real simple. We have a formula that says s equals r theta. That's the arc length formula. But if r is equal to 1, which it is in the unit circle, then the length of arc s matches the value of that radian measure. So each arc can be thought of as its corresponding central angle in radians. Now, for each real number s, we can assign values to each of the 6 trig functions. If s is a real number that, when associated with an arc of length s on the unit circle, has associated point x, y, then we define the circular trig functions as follows. Sine of s is equal to y. Cosine of s is equal to x. Remember, s is the arc. Tangent of s equals y over x, rather the arc length. Cosine of s equals 1 over y. Secant of s equals 1 over x. Cotangent of s equals x over y. Now, you should already be suspicious that these definitions look awfully familiar. That's because they are. They're essentially the trig functions we defined previously in a circle of radius r. In other words, they looked like this previously when we just had a generic angle in standard position with any radius r, and here was our trig functions. But in the unit circle, r is equal to 1. Thus, these are the same x, y, r definitions as before with radius equal to 1. So all the r's become 1s, and we end up getting these definitions. The main difference between these definitions and prior definitions is subtle. The circular trig functions inputs, the s's, are real numbers associated with arcs on the unit circle as opposed to angles. This will allow us to view, something else changed. Nope. This will allow us to view trig functions as functions of real numbers without having any contextual tie to angles or triangles. Their inputs represent points on the unit circle. So for example, in physics, you could think of s as measuring time or something. Now, such a relationship does always exist, if not stealthily behind the scenes. In other words, even though this is independent of triangles and angles, it's not that independent because we can always draw the triangle that takes it back to where we were. So it's just a third way to look at something we've already seen before. Now you try. Pause the video and try. Again, there are no problems to try here. But the sooner you commit circular trig function definitions to memory, the better. Mostly, you need to know that cosine of s is equal to x, and sine of s is equal to y. In other words, on the unit circle, the x is the cosine of the arc and the y is the sine of the arc. Now, once you know those, you can use reciprocal and quotient identities to derive the definitions of tangent, which is sine over cosine, so it's y over x, secant, which is the reciprocal of cosine, so it's 1 over x, cosecant, which is the reciprocal of sine, so it's x over y, and cotangent, which is either cosine over sine x over y, or the reciprocal of tangent. Either way, it's still x over y. So at least know cosine equals x and sine equals y. Oh, and that's the end of that video.